Okay, so let's start. So that's basically the test plan. So as I mentioned, test plan it is kind of a rule book that include everything and basically estimation, the scope, the strategy to entry exit criteria. Everything has been clearly documented, defined in test plan, and it has to be agreed by each and every stakeholder of your project, that including technical development, business analysis, project management, and your client as well. So everybody's responsible to review it and agree, because quality is owned by everyone, right? Quality is not only limited to the test engineer or testing team. So it's overall ownership to achieve the given defined quality, right? So because of that, test plan will do a greater responsibility on achieving the quality. Because of that, it has to be reviewed and agreed upon. Okay, let's see what these are the basic content. So basically, your organization test policy and strategy you need to be included, and your development life cycle, methodology, and those things how we are going to use, and the scope of your testing, the objective of your testing, and risk, how we are going to identify your risk and how we are going to mitigate your risk and constraints and testable areas, and all these reviewers resources and all this information has to be included basically in environment rules, and all these roles and responsibilities. So everything has to be included. So some of them we already discussed part of your previous session. So one set of things that we didn't discuss, we'll discuss with today's session as well. And we'll look at what are the other areas that we are going to include into a test plan that we haven't discussed so far. So basically, there were certain activities that we need to perform. So basically, one key thing is we need to determine our scope, objective, and the risk of the testing. Basically, so that identify risk of the testing, and that will help us to identify the test strategy. So that will be key part of it. And and we will be using to make some decisions. So this information will require to do decisions, and how we are going to start testing and testing and all those things, and especially scheduling, and when these different tasks will be performed, and all this information, and how we are going to monitor and control, and your budget and test tools. All this will come up in, right? So I think this is the one of key area that will require to include in test plan, and it will be part of planning, did part of planning, as I mentioned previously. So test estimation is one of key things. I think we discussed this last week. So because of that, I'm not going to deep dive again. But basically, I discussed there are two different type of techniques we usually use. One will be the metrics-based technique and expert judgment or expert-based. Based on one of these techniques and based on the different frameworks what we have for the estimation, so we can do the estimation. So estimation is a one of key area part of planning, right? So you need to do the test estimation and planning part of your planning activities. So I discuss separate part because it's a large area. So and these all these things are the factors that influence the effort, specific product development process, people, and your results, characteristics. Those all these things we discussed in the last time, right? So because of that, I'm not going to deep dive again. So second one is the schedule. So it's also part of planning part of it. This also we discussed last week. So how we are going to derive schedule. So basically we will have a different activities to achieve and different deadlines you will to achieve. Based on deadline and criticality, you will be prioritizing and you will align your schedule. You will plan your schedule. Right? So that basically these three areas, uh, test plan, schedule, and the estimation will be part of key part of planning, right? Quality planning part. So then the second area is quality assurance. So quality assurance also have a great area to cover. So we looked at what this quality assurance. It's basically the process part of it, right? So test organization is one of key thing. So I think part of plan the quality assurance. So this is a one of key thing that we need to uh, think and what we need to have. So that's the independent testing. So testing always has to be independent. That's a fundamental requirement in the software testing or software quality assurance. The reason is, so independent testing is something we object. That's one of key objective. Even we are running in the agile or latest new development model and this, so we expected to testing has to be conducted independently, because independent testing is very essential. Because if the testing is not independent, if it is not a separate party, it is not an independent party, so there will be a lot of dependencies coming in, and you might not be a lot of challenges that when you are releasing a product with a greater quality, right? So because of that, the independence or either self autonomy has been given to the testing team. So basically, they will not report it to your technical team or project architects or something like that. So they will be separately reported to a maybe a project management or some management lead team, but they will be independent part. So they will be separated out. Any given project, even we are running in Agile, the quality assurance team or the software testing team has been separated out, and they have to work independently from the rest of project team. And that's why the test assurance plan, that the plan that I mentioned previously, has to be come up with testing team, and everybody has to review and agree, because that given the independence and them to make it independent testing. So that's a fundamental requirement. So absence of independence, a lot of testing difficulties will achieve, and a lot of challenges will come in the testing process itself. So independent testing is one of key area, because they have separate ownership, separate independence, self autonomy within the governance of the organization. So software testers has their own governance model, right? That's the one key thing that probably we'll learn a little bit later. So let's see what it is actually. So few things. Um, so independence will help you. So basically, because you could will be easily recognize failures, defects, and things to improve, because you know you don't have any dependency with other teams. So if you looked at the project develop, so I think the same development team is doing the testing, there will be a lot of interest of conflicts coming in. But if it is done by independent parties, so software testing is conducted by, or software qualification is conducted by independent party, they will have their own autonomy, and their conflicts of interest will be very minimal. So because of that, they will have their own view, and they can verify or the challenge or disapprove some of the assumptions taken by some of the stakeholders or some of the parties of the project. So they can challenge, and they will have that, because of the independence, they will have the rights to challenge the things and get things correct. So because of that, most of the time the independent testers or will be outsourced party or independent vendor or separate party of the organization, because of the independent, and they will have their own ownerships as well. So those are key benefits. Because of that, a lot of quality improvements they could be able to make it without having many biases or any conflict of interest. Right? So that's the value of having independent testing teams. But same time, there are drawbacks, right? So if you think about positive side of it, there will be negative side of it as well. So one key negative side is they are isolated from the development team most of the time. So there will be a lot of isolations, and sometimes because of that, lot of team collaborations might be get fail, because of if somebody go over independence. So sometimes we would be able, there will be collaborations also required with the agile especially. So right now we are in a mode of agile development model methodology, so we need a lot of collaborations. But if you go too much of independence, sometimes collaboration will get fail, and because of that, the testing team or QA team get isolated. So that's one of key drawback. Sometimes because of the independence, the other project stakeholders might feel the QA team is a bottleneck, okay, because of their recent defects and they are delaying the releases, and that they might look at the testing team or quality assurance team, that aspects. So they might feel this team is kind of a bottleneck, but actually they are bringing the value. But they might feel if you go for further independence, sometimes other teams might feel it's a bottleneck for them to deliver the things very fast. Because of that, they are the people who are trying to slow down the process, something like that. And same thing, so if there are strong independent system teams are available, development team might get lose the responsibility of quality. So they might feel okay, there's a separate testing team, they will do everything perfectly, so we don't need to much worry about our quality of development. So we might have a lower attention on the development, because we can, the quality QA team or quality assurance team who running independently will catch all these defects and make the product quality better. So because of that, they might lose the sense of responsibility. So that's a disaster, right? So that might happen. And even I have seen that happen in some of the projects, even within my experience, because of the independentness of the quality assurance team, they feel it's their responsibility of the quality. Quality, basically quality is everybody's responsibility, not the quality assurance or QA team responsibility. So basically QA team's responsibility comes in the identifying defects and identify the information of this application that they are under testing, basically identifying defects. But when it comes to quality, so it's everybody's responsibility, because you can't just identifying a defect, you can bring it to the quality. So bring the quality, you need to have proper coding standards, proper coding practices, and everything coming from the beginning. The proper requirement has to be developed, and everything will be better when everything has been done perfectly. Only you could be able to build a quality product. But because of the independent testing teams, but other teams might also feel it's not their duty. So if they feel it, that's a danger. And same time, the testers, if get isolated, they will not get the correct information of the requirement or the code or some of the releases. Some of the information, because of lack of collaboration, they might not get, and they might have to put a lot of effort to unwanted areas. So that's also a challenge. So that's the key challenge what we are seeing, being independent, but same time being, we have to be independent and self-autonomy. Yes, so that's a problem. So QA has to be independent. Same time, being independent is a challenge, because we have to collaborate. So that's the fundamental challenge in front of QA team has today. There has to be, it has been required to be independent. Same time, being independent is a challenge. So how far you are going to manage these two challenges, become a greater QA or quality assurance or testing team. So if you are unable to manage these challenges, you will might end up with collapsing your projects or collapsing your product quality or many other problems. So because of that, testing is one of toughest tasks in a software development life cycle. Right? So they have been asked to achieve something very difficult to achieve. So that, but keep in mind, the independent of testing is a fundamental requirement that's required for any given project. So next thing is different roles. I think we discussed slightly on different roles: the test manager and test lead and test engineer, senior engineer. Basically, we will have two different roles. One is either test manager or test lead. That's a leadership role. And senior engineer and engineer, these are the engineering roles. So basically, we will have two different type of role: either leadership role, it may be manager or lead, and engineering role, it will be engineer or senior engineer or tester or senior tester, something like that. So basically, these are the two roles, and they have typical roles, right? Typical R&R. So manager has to do a lot of documentation, estimation, planning, introduce matrices, decision making decisions, support the test, implement proper testing process and support it, coordinate it with many stakeholders, and monitor and control the application quality and reporting and initiate the process, and especially budget related activities. And you need to guide and promote testers, test team, and all this. And so you need to develop skills of the engineers and all those things you have to do. The testers, again, the leads tasks are also somewhat similar to it, but a lot of managerial tasks go to the management, and less lead managerial tasks come to lead, but mostly they both are equal. The senior engineer and engineer tasks are again similar. So they have to review and contribute to test plan, but they have to review these stories, identify test cases. You have to write the test cases. They have to set it up the environment. They have to do the test execution. They have to prepare test data. They have to report the defects and they have to automate the tests, and they have to review tests who is done by other QA engineers. All those things part of engineering work. Right? Basically, design, writing, developing, generating, reviewing, executing, all those are part of engineering or senior engineer work. So these two roles are very essential. So either leadership or either engineering roles will have a part of your testing process. You need to clearly define these processes, so then only you could be able to develop your quality assurance plan. So these all this information will be part of your quality assurance plan. You have to clearly define R and Rs, unless people will get confused. So sometimes engineer might get confused, the task that he's supposed to do in his project is correct or not. So senior engineer might have confusion whether the activities is performing or correct or not. So because of that, or even manager or lead. So because of that, we have to very clearly define these tasks, roles, and need to document it in a test plan. Right? So we looked at a test plan and finally, but this will be part of your test plan. This information has to be included into a plan clearly. So very clearly, you need to have this information. So next, one of fundamental process activity that we need to very clearly define entry and exit. So any testing activity that you are going to perform has to have a entry criteria defined. That basically, if when we are entering to university, there are certain entry criteria as we mentioned. Right? You need to pass the A level in the same year, and you need to have minimum 3 passes, and you need to have some courses they have defined. You need to have C passes for the English and something like that, right? So certain criteria, and if you want to study computer science, you need to do the you need to do the combined maths, chemistry, physics, and OIT or something like that, unless you won't be able to do the register for your computer science degree or something like that. So there are those are entry criteria, right? So various entry criteria are defined when we are entering to university based on the course, right? Based on the course we are going to follow, right? Similarly, based on the testing what we're supposed to do, we need to have very clear exit entry criteria has to be defined, because this entry criteria will govern whether we are start correctly and correct time. These are the few examples, right? So basically the available of the requirement, user stories or requirement, and whether you have clear clarity of this requirement. You understood the requirement correctly. So that's one of essential things. So because you need to have a requirement, that's the first thing. And then you need to make sure you understood the requirement. So if you can't understand the requirement, that is come up as a user story because of lagging of information or one of some reasons, then it won't be entry criteria. So your entry criteria will be to have requirement plus to have a clear requirement, understandable requirement. So that both are fundamental entry criteria. And availability of test items. Basically, if we are going to test something, then you need to have the code deployed correctly. You need to have deployments or something like that. And you need to have test environment. So you need to have independent test environment. You can't test on developer machines. Your testing environment is also independent entity. You has to have an independent testing environment where developers don't have access. Right? Test environment has to deploy by test team or deployment team, and it shouldn't have any access to the development team, and it should be independent. And we need to have this kind of environment, then only we could able to do testing. And availability of required tools and test data, test cases. You have to write test case, and it should be available to start execution testing. And if code is developed by a separate development team, that has to be unit tested, and testing has unit developer testing has been completed, and a relevant code review has been done. All this information you need to verify whether all these are achieved. If none of things, so code has not been correctly implemented, code review has not done, unit testing has not done, you don't have test environment, if you don't have test tools, If you don't have test cases, then you can't start testing. So then entry criteria we consider as a fail. So you integrate, if any of these entry criteria is fail, you have to reject the application, and you should not start testing. Basically, to start testing, entry criteria should be matched. So that's why we need to mention entry criteria in our test plan, because if we haven't mentioned entry criteria in test plan, the project management team or development team or the leadership team will come and push you to start testing, even you don't have a proper code, proper test environment, proper test tools, proper test cases to start execution. Good. So that then you will be in trouble, right? So if you have clearly document this, these are the entry criteria of functional testing. So then, and everybody sign off this test plan in the beginning, then they can't come and force you to start testing if none of entry criteria are matched. So basically, code should be available, code should have tested, code should be properly reviewed, code should have deployed in the independent environment, and all this will be an entry criteria. Very essential, right? That's a fundamental requirement of software testing. If you don't have clearly defined entry criteria, then you are in a mess, right? At the same time, so when you are going to complete it, I think all the entry criteria are green, you started testing. But there should be a defined exit criteria, because you should know at what point you are going to complete your testing. So you could, because you just can't execute the test cases and you can say you are completed. Your completion need to be measured. So this measurement has to be marked as exit criteria. So basically all the planned test cases are executed, or maybe 100% execution coverage. And out of 100%, at least 95% of test cases should pass. And all the requirements are covered part of this pass test cases. And if there are unresolved defects, open defects, that everybody agreed to keep this open defect and release the application. And if there, and sometimes we might have put, there shouldn't be a zero high and critical defects, maybe medium and low defects, we might have some percentage defects, but there shouldn't be any critical high defects, something like that. And all these matrices are under the level of the expected numbers, right? All those things we have to mark it as exit criteria. None of exit criteria is achieved, you can say your testing is not completed. Because of that, the application not ready to go, like application not ready to go to the production. So think like that, if you have 100 test cases, but you only executed 80% of 80% test cases, because the rest of are blocked because you don't have test data. So then your coverage is 80%. So then you can say, I have documented we need to have 100% coverage and everybody agreed, because I don't have 100% coverage now, it's not ready. So think you executed all the test cases, but out of 100 test cases, 20 test cases got failed and there are defects, open defects. So then your success rate or the pass rate will be 80%, because out of 100, only 80 test cases are passed. So your pass rate, but you have defined you need to have 95 pass rate. So then you can say, so my 95 pass rate is not achieved. So because of that, I need rest of remaining defects need to be fixed by development team, and I have to re-execute and I have to do the regression testing and complete my execution until it reach 95%. Right? That's something like that. So think you achieved 100% executed, you have pass rate of 95, right? 9 out of 100, 95 test cases pass. But there are 5 test cases failures, and these 5 test cases has few critical and high defects. S1, S2 defects. So then you can call it out. My exit criteria is 0 high and critical defects. If it is mentioned in document and everybody agreed, that's industry standard as well. So ideally, if there are open, critical and high defects, it is not allowed to release for go live or application production. So if we have documented it clear in exit criteria and everybody agreed in the beginning, So if the reality is there are, though you have 100% pass rate, though you have 95% of success rate, 100% execution rate, and 95% of pass rate, still there, if there are open issues that is critical and high, you can say until these critical and high defects fixed by development team and retested by QA team, this is not ready to go. You can stop your release because you are the people govern the quality in some different aspects, right? So that exit criteria has to be clearly defined in your project plan, right? That's very essential. Right? Exit criteria and entry criteria are the key two things that will govern your project, your quality part, your testing. So because of that, this very clearly need to define in a project, in your test plan, quality assurance plan. So are you clear after this point? This is very essential steps, right? Because all this point has to be covered, and developing a test plan will be a part of your assignment as well. We will do a hands-on session on it, right? These are theory part of it. We'll do a hands-on session, and after that you will get the assignment one, the first assignment as the completing this quotation of test plan. So because of that, keep in mind very clearly all this content, because that will be required to do your assignment, right? So this assignment is fundamental requirement for your exam. So because of that, make sure you learn this very clearly. If you have any questions, please feel free to raise your hands and ask it, or even you can use chat, or you can ask later even if required. So far, I hope all good. If not, please feel free to ask any if you have any questions, right? Okay. So next fundamental requirement is monitoring and control. Basically, we need to monitor and control our testing process. If you are going to control, you need to monitor, right? So think if you are driving a car, so you have a set of monitoring, right? You can monitor there is speedometer to monitor your speed, and there is a fuel gauge to monitor fuel amount, and there's a heat gauge to monitor engine heat and things. And there are few in new cars, there are many monitors like pressure monitor of the tire, and RPM, and various things, and battery, and many different things. And in EV car there are many different items. Lot of monitoring dashboards are available inside the car, and by looking at these values you can control. So if you feel if you are go exceed by 100 kmph in a highway, so you can control the car and you take your foot out of the accelerator and you can reduce it, right? So if you feel the low amount of fuels showing the fuel gauge, you can go to a pump station and pump the fuel, right? So if you feel its engine is getting heated, you can stop it and wait until it get heat down and monitor what is further. So you can control your car. If you notice your tire has low pressure in your dashboard, if you monitor it, then you can go to a tire house and get pressurized your tire up to the correct level, right? So that's the control part. To do the control, you need to have monitor. So that's why there are a lot of monitoring dashboards in car, right? If you looked at aeroplane, right, plane, so there are a large amount of monitors because they have to monitor various conditions, wing, different wing criteria, cloud criteria, various atmospheric criteria, lot of things to monitor. Based on that, he need to pilot the plane, right? So the pilot has to control the plane. So to control the plane, you need to have correct monitoring. You need to have correct monitoring dashboard, right? Similar software also, you need to have correct monitoring dashboards. Then only you can control your software developer process. So when it comes to the monitoring dashboards, there are many different matrices that really essential to monitor. So in a car speedometer, fuel gauge and heat gauge and tire pressure and all these things are key essential things. Those monitor, those controllers, those monitor, those dashboards are there available from the very long old days, right? Similarly, we need to have monitoring controls. So we call matrices. So here in software development, we call matrices. We need to have certain matrices defined very clearly if we are going to monitor. So basically, there are three few different type of matrices. So I can uh, share with you. I think here. So one thing is if it's about code, so you can have defect density or defect severity index. These are the two key matrices. So defect density is how many defects available for a certain code line of codes. You can measure the size of the code using the line of code or either number of tests that you have. And based on that you can measure or either defect severity index. So defect severity index you can measure based on the severity of if thing you have 100 defects for a 10,000 code lines, so then you can find out what is the defect severity index. Basically, if you have 100 defects, maybe 10,000 code lines, then you know it's a point 0.1, right? So point 0.1 is the defect severity is out of this 100, you will have few, you might have 10 high severity defects. Then we will be multiplied and you will have, so we'll think you have S10, S1, S2, 30, S3, 50, and S4 remaining. So how much? 10, right? This is the you have. Then your defect severity index will be like you have to calculate. This is a formula. So it will be a formula like that. So 10 multiplied by 5 plus 30 multiplied by 3 plus 50 multiplied by 2 plus 10 multiplied by 1 divided by 100. So this is defect severity. So here, the why we are measuring this, sometimes we have large number of defects, but majority low and medium. So then your severity index is low. But you have very few defects, maybe 10 defects, but all the 10 defects are high severity. So then it will be a problem for you because if the defect severity index is very high, your code quality is very low, right? So that's why we need to measure this. So when it comes to the code, we will measure in these kind of matrices, right? And if it is testing, so you can measure defect to remark ratio. So this is all valid defects, verified all reported defects, something like that. So the old value, sometimes when the defect that you are going to report might not be valid, everything might not be valid. Think you have report 100 defects, but out of 100, 80 valid, 20 as rejected because those are not valid. So then 80 divided into the 100 and your defect remark ratio should be 80. So ideally, the industry standard is should be 85% above it. That means you can have some certain defect rejections, but at least it need to be have some certain values which have proper defect remark ratio. So those are the few matrices that we can measure in software development process. But there are many other. So other one is we can have burn out, burned out uh, defect ingestion ratio. So how many defects raised per day? Defect closure ratio. How many defects fixed by daily? So these kind of matrices you can measure. So based on that, you can have various numbers and you can have various matrices. So you need to track these matrices. So based out of it, you can tell whether your software development process is correct or not. Right. So that's what will be required. So these are the few examples. I Here I have made it, but if you can Google it, if you can use ChatGPT, you can use various matrices available in the software development life cycles that we can use. So the few matrices I mentioned are the key, but it doesn't mean you need to track only them. There are many others. Any questions here, or do you have anything to clarify here? All good with this? Okay, so let's move on. So these are the few matrices. So these are the things how we are going to measure, right? So these are the burn up charts, burn up some defect injection charts, something like that. And these are the few different matrices and how we are going to measure it. And based on that, you can measure. Right? So other thing is, so reports. So this is very essential. So these matrices before going to the reports, you need to clearly mention your test plan, which matrix you are going to use in your project to test to measure the quality of the testing, right? You need to clearly mention in your test plan, these are the matrices I am going to use to measure my testing process and software development process, right? So it has to be mentioned in test plan, quality assurance plan. So next thing is you need to clearly inform what type of reports we are going to use for a reporting. Right? Basically, in reporting, we have three different type of people. One is operations people. So, operational. Right? So operations means your team, developers, QA, PM, BA, your team. So they need to know your testing status, right? Your team need to know, development team need to know, PM need to know, business analyst need to know your status. So that's it. So we need to send a daily report, daily test report for them. They need to know what's happening, how many defects raised today, how many defects fixed, how many test cases passed today, how many test cases failed, those information, right? Daily test report. So there are different tactical people in a project. So tactical people means management team, right? Your project management, your QA manager, your program manager, few leadership members, right? So they need to know how this project is progressing. So basically, they might not need to know daily how many defects you raise or something like that, right? They don't care. They want to know whether you are going in correct direction, whether burned up, burned down charts or the injection, defect injection charts for a week time period or something like going properly. So this probably we can have a weekly report. The third type of people are strategic. So strategic people are likely very leadership CEO of your company or your head of division or head of technology or your client. So he might not worry about your daily test cases or something like that. They will worry about how we are achieving the project budget, whether you are exceeding the budget. We are going to achieve you are going to deliver the correct day as you promised. Whether goal will happen same day or will there be any impact. These are strategic information, so that has to be shared based on your requirement, based on your people, right? We can't say it's a weekly, sometimes it may be weekly, sometimes it may be bi-weekly, sometimes monthly. Based on the project size, they might need that information. Basically we will have three different type of reporting, but basically we need to have daily and weekly report. That's a must, because sometimes strategic team will communicate by different team, not you, right? So because of that, you might not need to much worry about strategic reporting, but operational and tactical reports are very essential. So daily test progress is kind of operational. Tactical report is a summary for a week or something like that. And so that you have to mention in your test plan. I am going to report, this is my report audience, and this is how frequency, whether I'm going to do it daily or whether I'm going to do it weekly, and what is the frequency, right? So that you have to clearly mention in your test plan. Is it clear till now? This is very essential area as well. So this has to be very clearly communicate, right? And documented in your test plan. Okay, so basically these are the process part of it. What we have discussed till now is a process part of the latter part of it is a control part of it. So basically that's a test, purely testing and test execution part of it. So we'll see what's the control part of it as well. So basically there's a verification and validation, two different contexts that we need to do. So in the part of our testing, we will do one thing is we'll do verification, other thing is we'll do validation. Verification is whether we are building a product right, because we have a correct process. Whether we use correct development methodology, we are using correct measurements. So whether we are building the product in correct way. හරියට project එක කරනවද කියන එක තමයි මේකෙන් කියන්නේ. Whether we are building the product right. Verification. The validation is, are we building the right product? We are building a right product based on the requirement, whether we are building the correct product. So that's what fundamentally testers going to validate. Testers will validate whether developers are build the right product, whether developers are use the correct requirement and build it correctly. So validation. Verification is a wider audience. Everybody has to make sure whether we are in correct path, whether we are in the correct process, right? So basically these two differences will be validated part of software testing, right? So where basically verification is kind of a static testing. So it may be reviews, inspections, guidelines, walkthroughs, process enhancements, right? So that's everybody's responsibility. Right? Not only the quality assurance responsibility, the project manager, developer, PM, business analysis, management, everybody, and QA, everybody has responsibility to making sure whether we are developing the product in correct process, using correct process. But when it comes to QA, we are purely responsible whether the correct product is developed, the correct requirement is developed or not, right? So that's what exactly required. So that's where black box, white box, unit test, integration test, different testing types come in. So validation is part of our quality control, and quality control is part of validation. It's very clear. So the verification is not a part of controlling. It's part of your entire project life cycle. But when it comes to the validation, it's clearly part of quality control. So testing, that's what we call testing. Is this clear? This is very essential part of concept that we need to know, because that need to be clear. If we don't know this, we can't clearly derive our test plan. Right? This comes. Okay. The risk and testing, so that's basically the fundamental part of risk that we discuss, right? What discuss project risk and how we are going to develop the product risk. So we discussed about the risk management concept, and based on using the risk management concept, the very first day I discussed. Give me 1 second. More step, huh? Yeah, we'll come. So this part we think we completed the very first session. So this is basically the risk-based testing. So risk-based testing is a part of test control, quality control. So you need to have clear steps to identify software test risk, and based on the risk, you need to identify your uh, testing strategy, and you need to find out test types, right? So I think this is initially we discussed, and hence I'm not going to deep dive this part. So then defect management. I think this is also we discuss defect management, defect life cycle we discuss the second day. So again, there is certain criteria, right? So based when we execute in the test cases, we need to report the defects. So defect reporting, we have different constraints. One thing is severity and priority we need to maintain. We need to clearly report defects and all those things. I am not going to deep dive again here. That's also part of quality control. So the last part, so that I think come up with not the control or any other thing, but it's a management part of it, right? So it's basically the team management, right? So we need to make sure that we manage the team correctly, and the team management is also fundamental part of software test plan. Right? We need to focus on. So this is how it will be basically. So people skills.